Okay, I'm in handheld mode. It's just not good. I got the new gear printed, designed and printed, and I'm going through the puff, and what you're seeing here is the fan pulsing on every puff. Puff, 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 puff. And I'm at a very slow rate, four chuffs, not even 2 volts. And it's working. It's working. There's a green light down there, and it strobes. My glue broke. I got too rambunctious with my wiring, so I'm holding this on. But the glue is there. But the trick here is the pulsing is doing what it's supposed to, and all that good stuff. And then there's and I did the horn, or the steam whistle. I tried to do the whistle louder. I haven't figured out how yet, but I will. Andy will help me, I guess. So, we're not too shabby. I can't tell you the bell is fixed. I can't say that. The bell has a weird sound and doesn't like it, but I'm going to work on that. The whistle and the chuff are working beautifully, so I know it will work. I just have to focus on that. Okay, so that's been my day, short of when I had to go give more blood for some reason. They missed a test. Nothing bad, just that they missed a test. And so that kind of messed up the day. Anytime we go out, Margaret thinks she needs to go shopping. So we went to the nearest grocery store and got stocked up on whatever she thought we needed. But good news, I have one of my earlier prototype boards I brought back to life and fired it up, and it runs. I'm building a test bed for it to be part of a sensor testing station permanently here. I would never send that out to anybody. And then I have Leon's remnants. They're programmed, and I'm setting up a test for him. I have his engine and his chassis. I'm going to mount them somehow on something that they can kind of all line up, sort of like this, only a little more structured. And we'll be able to put power to it and adjust and tune. He's got a different trigger assessment, so I got to go look at that and see what it needs. And it might be even simpler than we think. I'm not sure. I'll find out. And I don't know. There we are. That's kind of what's going on. Boom, it just fell out. The glue, it has a hole for mounting, but it's way off somehow, so I got to work on that. What I'm going to do is reprint this so it's longer. And so that hole then would be used to screw this to a pad, and the pad would hold it in the opening over the gear. But it's all in all, we're there. And Andy, he's a good guy. He really is a good guy. Thank God. I'll show you what happens here. There's a sound wave, you see, right there, and I can open it in. There, you just heard it, right? That's chuff. Okay. And then what I can do, if I'm anywhere near coordinated enough, I can go to my Audacity sound editor. Yes. And open it. See that? Open it in sound, and you can hear this and see this. And you see how it goes through. And what I did was, oh boy, I don't know if I have one down here that hasn't been, tweaked. I'll bet you this steam whistle is old. It's been removed. Dog. I was trying to find an older one so I could show you recent files. Let's try this one. Oh, okay, that looks about right. Okay, very long tail back here, And we don't like that. And this is really too long. It's almost 3.5 milliseconds. It's too long. Yeah, and it runs into other things. Now I have shortened this. I've changed it. Let's see if I can find it in my file here. Steam whistle. Oh, sorry about that. That's already been done. Well, okay. This isn't going well. I'll tell you what. I'll do it again. I'll just do it again. Here we are. What I can do is I can identify an area that I want to crop. And what I'm going to do is I'm just going to get rid of that stuff. So I've highlighted it and I'm going to say delete. Boom, it's gone. Okay. Now I want to highlight an area where it's got a lot of noise, but I don't want it to be that loud at the end. I want to have quite a bit of silence. And they have something here called effects. And you can go into the effects and I can do a fade out. You're like, hey. Boom. Did you see that? Fade out. I'll do it again. Watch it. Effect, fade out. Boom. It shrinks this down. Now let's hear it. Well, no, we want to hear the whole thing, not just that. So I got to select the whole thing. It ends shorter and faster. It starts short, ends short. It's about 2.5 milliseconds. It might want to be a little shorter, but this is how you can edit the sound. When I started this thing, it was probably 4.5 milliseconds. It was way long. And so what I was going to show you, open these and open this one, for example. Boom. You can see it's 2.5 milliseconds. It's been shortened. It's been screwed down. And it's, boom, it's quick. Now, this one is H14. This is the very high speed. So this one actually needs to be shorter, maybe down to 0.15 or something like that, but I'll do it later. But this is the editing process of the sound bites. Note, save it. No, don't save it. Nope, don't save it. Oh, that's my printer thing. It's resting right now. Okay. So this is the list of music in Microsoft, and this is the music in the file that we have, not music but sounds. And so in the program, here you'll see output pin, and it says pin D5, and that's a sound, okay? And then there were some sounds that we're not using, and on and on. But when it calls up this sound wave, as I go down here, and I'll show you. Here it's calling for the steam whistle right there. See that? Steam whistle? It's going to call for this steam whistle over here, and it's going to be shorter, and that seems to be helping this screaming and overlapping sounds that we had when we did the mixer, when we have the right and left channel. And if one channel was, I don't know, maybe longer than the other, the sound was, they got in a fight or something. I don't understand it, but at any rate, that's the way it was. So I'm tuning the sounds. I'm picking the sounds I want. There's another one that I want. I'll play it for you. See what you think. Shoveling it in. Throw it in the hole. Shovel it in. Throw it in the hole. So that's shoveling coal. And I thought, when the train engine is running, you're going to hear chuff, 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 chuff. But if it's stopped, like at the station, and it's still running, the fan's on slow, I think we should put in shoveling coal when the train is stopped. So the fireman is shoveling coal every time the train stops. We have the sound, and we certainly have either extra ports or logic in here, because there's two sounds I'm not using right here. Two and 3 are not used. Those are commented out. So I could put in the shoveling coal. I just have to figure out how to make it play and then shut off when we're in motion and ding dong and chuffing. That's another thing. So I'm getting my breadboards put together. I'm going to be building more of these assemblies like this, where you have the engine and the board and everything in it there, sound, speakers, chuff, trigger, blah, 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 all set up. I'm going to do Leon's the same way, only different. I think I have a couple of wooden boards I'm going to use because I'll need a little pin maybe like this, but I won't need a big king because he's got the completed board. It's ready to go. That's how I'm going to work on that. And that's how we do the edit and the other things. Let me think through my head. I don't know. There's a few things that we had to do. Serial port not selected. Oh, I don't know. I did something wrong. I'll come back to that. Oh, I was going to load this to this, and it didn't work, so I'll have to figure that out. All right. Not worried. And then, oh, well, here's, you want to see this? This is kind of fun. This is my, the gear. This is the gear in how I'm printing it. This is how it comes through the printer. And that is the supports for the backside. And there were Andy's idea of the slots in the wheel. And then I had a touch-up paint in white. I don't know what I had this for. I think another engine or something, but I had white touch-up paint. I had silver, but silver wasn't working for me, so I put white paint in the groove. And this is the printed file. This is the get ready to go print. I'm going to hide this for a moment and show you. Here is the CAD file. And I've got one of my construction lines on there. There you go. So now I get over here and I can move this around. You can see how this gear looks and how it's made and the grooves that I put in. My little shoulders here are about 1 millimeter too long. I've got a 14 overall, needs to be 13. So I can show you real quick how we do that. One, you blow it up so you can see it. And then you select that surface, okay? And what I'm gonna do, I'm gonna try the easiest way, which is press pull, and I'm gonna do a -1. Let's see if I can do it. I can do a minus and then a 1. Do you think that did it? Yeah, look at that, -1, there it is. So it was 2, now it's 1. Then I spin this around, I get this surface looking at me, and then I have a button up here that says inspection, and that's a measurement. Now I want to know the overall distance between those 2 points, and it's 13. So I've cut it 1 millimeter. Now I got to do this other one. So let's go here and let's close that and let's click on that. And then when I hit my little tool, I got press pull again, and I probably have that number in there. Yeah, -1. Boom. No, not 14. -1. What are you doing? Where'd you go? Oh boy. This is when you do demos and you start them and then you think, maybe I shouldn't be doing this. -1. We hit -1, not 14. Come on, baby. Oh, this might take a while. All right. This CAD, CAD programs are very complicated and they have a lot of geometry behind the scenes. We don't even know. It's so complicated. Okay, so it may go off and do a bunch of math and come back and go, bing, I got it, or not. But that's okay. I got a backup button if I screw up. Believe me, I learned that the first day, okay? Back it up. I messed up. So anyway, that's how I did the gear this morning. These are the other parts that I have in here. There's the smoke. There's the northern tender I'm doing for another guy. There's the chassis for the Royal Blue. There's the all-wheel pickup. And there's another frame and some other stuff, the rolling road and the magnetic fields. All of the files are in this program, and this program, believe it or not, is extremely powerful. It's a great program, and it has, so you can see up here, it has create, modify, assemble, construct, inspect, a lot of capabilities, a lot of features. It's tied up right now, I can't even move it around, but it also has electronics, machine tools, and the actual diagram, the engineering drawing. So you could take all these dimensions and put them in an engineering drawing and have it. So this is from Autodesk, and Autodesk, we used it in the late 70s in the scanner business. Fabulous software. Back then it was so hard. Everything was cryptic, stupid, today, holy cow, I'm sitting here on an old PC. It's an i7, but it's old. Big, nice monitor and a lousy mouse, and I'm binging it. And I trained myself online for this CAD tool. So don't think you can't do it. Don't ever think you can't do it. Don't think you can't afford it. You got a decent PC is all you need. You don't need the big monitor. You can do it on a small, but you know, I got bad eyes and Margaret loves me. It's okay. But the software you can get as a hobbyist. You know, if you're a commercial entity, you're going to pay for it. But still, even then, it's only like $400 a year. But okay, companies buy it because it's a good deal. I like that software. The other thing I used that I showed a little bit of was the, I can get over here and get into this. Get this out of the way, get this out of the way, was my Simplify 3D. This is what's called the slicer. So when I come out of here on the CAD side, I go into the slicer side, and what this guy is going to do, if I go to edit the process, I'll show you. It creates what's called the G code, and these are G codes for machine tools, kinda, X, Y, and Z. So you go G1, X, Y, X5, Y10, F15, move to prime position. And in this case, these are just setups. This is like the starting script, okay? But when you get to the part that you want, that script gets very long and very complicated, and we don't have to key that in anymore. This software would take it. Like here I have 4 of my trucks that I made just the other day. These are the 6-wheel tender trucks. I have it upside down. There you go. And I have to make 4 of those, and I made 4 of them. And I have a heavyweight flatbed that I'm going to put them on and see how that works out. But this tool then, okay, let's pretend, I won't do it. It says prepare to print, okay? So when it prepares to print, it creates a look, and guess what? I can look at it in animation. And we're watching it print. I can move it faster and slower, but it's actually showing you how the material is going to be put down by the printer. And think of this printer as like a toothpaste tube, and it's being squeezed out by a motor, and it has a tiny nozzle, and when you squeeze it out, you're actually drawing that shape layer by layer, and you keep drawing it like building a cake with a layer of icing all the way up, and then when you're done, the part's done. It's great. So that's visualizing the G code. Then I come over here to this other great tool. I got lots of fun stuff. I got my Octopus print or whatever. Okay, so we have the CAD file of the part that I engineered, right, based on my need, came up with a shape, send it to the slicer, slicer sends it to the Octoprint, and the Octoprint will operate the printer. I have a camera, it may not be on, but I can watch it. I can watch the temperature. These are just stupid things. Fine. I have my list of parts down here, and it's all this is in G code already. So if I wanted to print a part that I already have in my file here, I just find it. Don't look at that. Atomic engine doesn't mean anything. I can find a firebox, so to speak, select it, come up here, and it's in this screen, and I make sure everything's okay. I see how much time is it going to take, how much filament is it going to take, and I say, okay, let's print that baby. So I can hit print, and the printer talks to the computer here, and it starts telling it, warm up, Mr. Printer. You start getting ready. I'm going to send you some G code, and you're going to print. So warm up that nozzle and get that plastic ready to inject down, and I'm going to give you the X, Y, and Z instructions in a minute. Once it's up to the right temperature, and this takes 210 degrees Celsius, just so you know, this particular filament, which is PLA, it's very common. I'm using carbon black because it's really black and I like it. And then it prints out the layers like I showed you, and we usually do a little bridge, or I don't know, we outline the part, so to speak. And I don't know why we do it. It just seems to be a good thing. And then we start the real part inside here. And when it's done, the printer just goes where it parks, and you give it a few minutes to cool down. Then you get your scraper and you scrape off the part. You throw that away. Then you take your part, and sometimes you have to do a little cleanup, something hanging off of it or something. You may want to file it. You measure it, you check it, you make sure it produced right. Like on this one, the diameter had to be drilled out for the shaft, because I told it 3.55, and it tried to make it 3.55, but when it came out it was 3.25. And that's because the material would swell and shrink inside the diameter of the hole of the gear. It's just the way the plastic works. So you check the first one, you see you're 3/10 of a millimeter short. So let's go over. Let's go to 3.85 next time, and it'll probably come in 3.55, and that shaft will go right through. I won't have to do any post-processing, drilling the hole out and filing it. Okay. Anyway, this is sort of like the whole process. I just thought I'd share some of this with you. And this is called a breadboard. And you have the components as you would have them in your circuit board, but instead of the circuit board circuits like this, instead of having the circuit board with the circuits and the parts on top, you have the circuits in wire, this wire we have, and you can move it around and poke it. You poke it in a hole. You want it, the circuit needs to go from there to there. Okay, here we go. Boom. Boom, there. Now circuit goes from here to here, and then you put whatever else you need to go. So like this switch needed to go to ground. This is a ground track over here. This whole track all the way up and down is ground. The one near the red line is 5 volts. So this button, when I push it, it needs to go to ground. So I tied that lug to that wire, put that wire to ground, boom. So the input here goes in for the sound, that goes to ground. Ground allows energy to flow in. When I push this button, it tells that little computer inside, that's a computer right there, that silver box. It says it, play sound demand pin 4, or something like that. And then you'll hear a bell or a whistle coming out the speaker. It has the wave file here. It sends it over to this boy. I know it kind of gets complicated. This is a sound amplifier, so it sees the wave coming in. It takes the wave and it pumps it up so it's a little bigger, and then it sends it out to the speaker, and then the speaker makes the sound. So it's amplifying a small sound into a larger sound by using the amplifier circuitry in here. It also runs on 5 volts and ground, and you buy those separately. So like this board, I just ordered some. I can get 3 for $10 if I shop around. This thing is probably $10, maybe $5. This battery charger board right here is $10 by its lonesome. So it's funny, the most fun, complicated thing is actually the cheapest. And why? Because they make them by the millions, and these they make by the hundreds. So they don't make the volume discount, economy of scale stuff. But on this one they can, because this goes all over the world. These are beautiful little PC boards. The squiggle line here is an antenna. So it has the capability of running off of a network as well as point-to-point. And what you see when we put this together, there's the power supply, or the reverse, right? Right there's the reverse. And that's the board, and that's it on its board. That's the power conditioner, buck boost. This is going to change. I'm going to have to use this charger and this battery. I can go a little further if you don't mind. With this battery, the idea we have now is to mount it on the back of the see that? It's a perfect fit. And we need a little switch, so we're going to put the switch right there too. And then I'm going to 3D print a little box that just comes up to here, screws up on both ends, and then the trucks swivel in front of it. So the battery is going to be underneath. It's heavy, so it gives us good ballast. gives us more weight, and it's out of the way. It's not gonna take away from my 5-pound bag that I have up here. So everything will still fit up there. The battery will go down below, plus the switch to turn it off and on. And we're gonna have all these sounds. And it also does the chuff configuration. As you saw, it'll puff the fan, and it'll make the chuff sound coordinated at the same time. And when the fan puffs, this fan would puff, it sucks air in through this vent, comes in here, gets compressed, and then it shoots it in a tube. There's a molded in channel that goes straight across the smoke and down and out, and over this lid that goes on here, hanging down as a heater. So the heater hangs down, and the oil in here vaporizes or evaporates. So there's a pool of oil just sitting there, a smoke. Oil, evaporated oil is smoke, okay? And it may be scented sometimes, you do Christmas or cherry pie or pipe or whatever, okay? So when the fan sucks that air in and spits it back out here, it goes right across and up. It will pull that smoke with it, and the smoke will pop out. So if it's sitting here going chuff, chuff, you're gonna see smoke, 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 smoke coming out of this. At the same time, that same pulse from this trigger is going to this PC board, to this amplifier, to that speaker, and it's going chuff, 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 chuff. So you're gonna see puff and hear chuff at the same instant, and your brain puts all that together to say, that chuff is making that puff. Is that cool? And that is the Puff and Chuff board system thing, okay? The motion control to the motor is still done with our rusty, trusty PC board that is a re-engineered Lionel. Andy has gone through this. We've updated and upgraded all the parts. It's our PC board. We pay for it, we design it, we build it, and then we stuff it, and then you guys can put it, and it gives you forward and reverse digital for DC motor. Now you know that all that lecture the other day was all DC AC. This is a AC open frame converted to DC. This is exactly what Gilbert did when he put the permanent magnets inside the fields. The only thing is, I've got different permanent magnets, and I put them around the armature. Oh, what a mess. Oh, me. Well, it's all put away. It's all not here. It's going to show. Oh, there you go. Here's one of my field magnets. This is the field adapter, okay? So the armature goes in the middle, and you see here, you see these little arcs right there. There's an arc. And over here, there's an arc. I have a magnet. I think. No, I do. That's not what I have. Here it is. I have some of these magnets, and you can see they are in the shape of an arc, a part of a circle, okay? And they, opposite fields, right, north and south, facing each other, they slide into those grooves, one there and one there, and that's the base of the magnetic field for the armature to get pulled in the direction we want. Then, these magnets that I found, I couldn't get bigger ones, and these were just not quite strong enough. So, I got a square rectangle, what I call a booster magnet, and I fit it right behind the arc magnet in my folder. It's a holder, and that's what you'll see here. This one's sticking out because I put two in there. Oh yeah, this is supercharged. Anyway, you put the arc magnet and the booster magnets in this thing, and this then replaces the fields when you assemble your motor. So you slide this on, you slide the armature in, and you put your brush holder on, you button it up, and then you put your brushes and springs and your clips on the back, wire it up, and that baby will run. Yeah, runs good. Now on top, you'll see I got these holes here. I put in brass inserts, which are threaded, and I screw down a little holder, and that's how I'm going to get the chuff pulse. In the old engines, we had a gear with a piston, and it went in and out and did the piston. The piston did two things. It pushed air through the casting for the smoke to come out, but it also pushed air through a little whistle, and it made the chuff sound. So you had a mechanical puff and chuff. What we have now is digital chuff and puff, and the beauty of it is, I don't know, it sounds better and it works better. You'll see. So this turns. I can't take it apart real easily, but here you'll see, here was an earlier version where I used actual fingers, and I put, oh, I can show you right there. Look, there's a piece of metal, a pie-shaped piece of metal, right? When that piece of metal came to the top, it connected these two fingers and it made a circuit. And that circuit was sent to this computer board as a pulse, a triggered pulse. So it would go chuff, chuff, chuff. As the engine spun this gear, chuff, 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 chuff every time. And when it got this chuff pulse, one, it made the sound through the amplifier, and two, what? Gave a pulse to the fan. Little boop. So a little puff of smoke would come out. So that's the trigger for the puff and chuff. That's a trigger for puff and chuff. This is optical. This is mechanical using fingers. I have another one that's mechanical using a limit switch. And I think the optical is cleaner. And sometimes when you have a mechanical switch and you push it down and put it in, engage it, it does this. It has a little, what we call a bounce. And these, they don't. They're digital, so they just go pump. With the other switches, they go bounce, and then they let go. And what happens when you get the bounce, this poor baby, he gets messed up. He's not sure what's going on. Do you want me on? Do you want me off? Okay, I'm just going to send a screech or something like that. And that creates problems for us. Now that you saw how I did, I trimmed the sound bites down 2.5 milliseconds, pretty tight. And this baby is now sharp and crisp when it pulses that trigger. And this made everything else work better. Everything worked better. Oh, and Andy was right on another thing. Well, he's right on about everything he's told me. This speaker with this particular material is a heavy plastic. It just rattles and makes noise. So I have this cloth speaker here is much better. This is a cloth speaker. I got it smaller. It's much better. This is a cloth speaker. It's the old standby. We used that for the electric railroad for years and years, and I still have some around. These are awesome. You can look at that. Look at that baffle. You know what can come out of there, right? Oh, big chuff. Big steam whistle. Oh, yeah. Okay. Oh, and the other piece that I really think you cannot be without is the rolling road. My God. I put a chassis on a rolling road as soon as it's built. As soon as the engine is together, I put on a rolling road and test the engine. I test the motor. And it pretty well stays on that rolling road until it goes in. It goes in the box to go somewhere or on my track. It just does, because everything you want to do, you're going to test it. Like I have my power supply, right? This is a 305. It's 30 is 30 volts at 5 amps. And boy, it will put out the power. This thing will rattle around. I better. Anyway, this makes power. It's awesome. And I can dial it down. And I can also dial it down for when I want to do a test of a sensor, right? And it had to have less than an amp. I can set that amperage so it does not go over. I can set it 5 volts, 1 amp. And that way I can safely test all my stuff here and make sure that it's wired right and it's going to do the right thing. Okay, I don't know what happened to me. I must have had too much coffee at lunch. Anyway, that's the update. It's not exactly what I'd hoped, but it is extremely positive. We're putting dots over I's and we're crossing T's is what it amounts to. You know, like this gear. Like I told Margaret, I worried about where to put this battery, and Jim Shea says, look, they have a box under this thing sometimes. It's for control wires and other things, so put a box under there, decorate it like it's something, and then put your battery in there, and it's perfect. Thank you, Jim. Good guy thinking. And then I have more room in my 5-pound bag for my 7 pounds that I have left over. I think this is going to be pretty awesome. It's just a matter of when and how and what. Tomorrow, Saturday, as far as I know, I have to mail a package, but that's it. Sunday, I think, is a free day. I say free day. It seems like every day I go somewhere and either get a shot or give blood. Next week, we're going to get the flu shot. Can you believe it? So every week, somebody's poking me with something. I don't like it. Okay, we're getting down to the end. This board, I'm having a little difficulty getting him fired up. He may be fried. I don't remember exactly. I have enough of these, so I'll just, if he's bad, I get rid of him. I got some others here, and I have some more back in the storage. So I've got boards. I don't have enough of these. I have to order more of those, and they're not cheap. That's what hurts, because you have to have enough. I need to build like 6 engines, 3 or 4 that I can sell or trade or barter, and then I have to have 1 or 2 of my own for test purposes and whatnot. So this frame will probably get a little modification, but it's going to be largely the same. I think so. And there's another reverse unit that goes with it. So that's going to get set up. This is going to get set up. That's 2. And I got another engine I want to build. And I got this board. I think I can get him working. I got another board over there I'm going to get working. Boom. We're going to be golden. And it's what? 10 after 5. So, not too shabby. I feel good. I'm hoping this comes across as sort of like progress and it's all good, but I know it's a mess. I know everything's a mess. I know sometimes Margaret says, oh, they can't see what you're doing because you have so much crap everywhere. I says, well, I can't help it. It's just the way it is. I see, I focus in on what I want to see. I'm hoping you guys can too. And I know I'm holding the camera because I had too much to go to. I wanted to make sure you saw how this happens and what goes into it and why it takes so long. Say you got lost. Yeah, my computer screwed up and it just happens. Okay, Christmas is sitting there. He's ready, pretty much ready to go. We got to do a little more decorating, but he's going to get up soon, I hope. And we're off and running. Okay, that's it. I'll post this. You guys can see what you think, and I'm hoping see some progress because I do. All right, Next Generation S, this is it. This is what we're going to do. And you guys can do it. You can do it or you can play with us. We can give you what you need, not expensive. We can print and build and give you the parts, and you configure and make your engine. I hope there's somebody out there that would like to do that, because I do. I don't know. And it's not for money. It's to keep the hobby going, keep the S-Gauge going. We don't want it to throw out, Everybody dies, there's nobody left. You know what that is? That's a chassis and the body supports for an extended range Royal Blue. Ha! Right. All right, I'm out of here. Gotta go, literally. Later.